The bar graph shows the win and loss record for a lacrosse team over a period of 3 years, and explain how you can apply the ruler postulate rule, post 1.1, and the segment addition postulate, post 1.2, when interpreting a stacked bar graph like the one shown below. The ruler postulate rule is that the points on a line can be matched one-to-one with real numbers. The real numbers that correspond to a point is the coordinate of the point. The distance between points A and B, written as AB, is the absolute value of a difference of coordinates A and B. So, the first idea that you need to come by when you see the ruler postulate is that we need to figure out how to make our graph into line segments. First, we need to identify some points. So for year one, in the lacrosse team, the beginning of the wins can be point A. The middle, where the wins are to be losses, point B, and the losses at the end would be point C. We do that for the same for all of the years. And you can see that there you can make lines out of this bar graph when you identify points. So now that we've identified all the line segments, we can begin to use the ruler postulate rule. Now the ruler postulate formula is right here, where x is subscript of 2 minus x subscript of 1 is equal to AB. We can apply this formula right here to the bar graph. For example, if we try to find the values for the A and C, the distance for A and C, we can find the values of all of the games that the lacrosse team has done in that year. But if we find, for example, AB, we can find only the wins of the lacrosse team. The lacrosse team is won how many games in the first year. The distance can tell us the value of the games, the number of games. So here we start with our equation. So we're going to first do the point AC, A and C, to find the total distance. We have the formula written. Okay, so we're going to we see that C is equal to 11 and A is equal to 0. So then you get 11, because that's the second x. You get 11 minus 0. And then 11 minus 0 is equal to 11, which you don't need absolute value would be 11 still. So therefore, the value A to C is 11. Now we have a second point. We can get the second point for this. So that would be A and B. We can find the distance for the value of how many games the lacrosse team won in year one. So you would do the same thing as we did before. You have the formula below, which we're getting AB for. We take for A, we know is 0, and we know that B is 6. So we're going to do 6 minus 0, and that would be equal to 6, and absolute value would still be 6. So the distance from A to B is 6. Then we're going to move on to year 2 now. So the same thing with year 2. Let's go and find the value for B and C. Now that would tell us the total number of losses, BC. That would tell us the losses, because the distance would be equivalent to loss. How many games the lacrosse team lost over in year 2. So we have BC, where C is equivalent to 12 and B is equal to 7. So we start with a lovely 12. 12 minus 7. Now that would get us a total of 5. Well, with absolute value would be the same thing again. So here we take B and C, and the total losses would be 5. Okay, and we're going to do the same thing again, but we're going to do it for AB this time, but this time for the wins. Okay, so for AB, for B is equivalent to 7, and A is equivalent to 0. So 7 minus 0 is 7. And again, even with absolute value, it would still remain 7. So then we would find out that this is 7. Okay, now we're going to go on to year 3. We're going to find it for BC, and we're also going to find it for AC, which will be the total games. So we're going to do again, B is 8, BC, and then C is 13. So it will be 13 minus 8, and that will give us a 5. And then we're going to do it the same thing, but we're going to do for AC. We got C is 13, and then A is 0. So it'd be 13 minus 0. And that would be a lovely 13. So the total would be 13. Okay, so now we found a few values for each of the years. And that can tell us a lot when it comes to what wins, what losses, and what total number of games they have played. But there's another way that you can find values if you already know the values of 2 segments. We can use a segment addition postulate. Now, the segment addition postulate says that if B is between points A and C, then AB plus BC equals AC. So we can use that to find the values that we didn't actually find when using the ruler postulate. So we know our new equation we have, the new formula we have for segment addition postulate would be, again, it would be AB plus BC equals AC. That means that B would be in between points A and C for this formula to work. Now as we can see in our lines, that B is in between A and C for each of our years. So this formula can work for this graph. Okay, so we know some values for each of the years. Now using the ruler postulate rule, we can identify the last value for each of the years that we haven't yet solved. Okay, so we know that AC for year 1 is equal to 11, and AB is equal to 6. So we can use it here and substitute that in. So 6 plus BC, we don't know what BC is equal to 11. Now what you can do here is just solve it like a normal equation, and you subtract 6 to both sides, and you get that BC is equal to 5. So you know BC is equal to 5. Okay, now we can do the same thing for the next one. And essentially what the segment addition postulate is saying is that AB and BC is equivalent to AC. Or when you add them both up, you get the total distance, AC, the whole line segment. The whole line segment. Okay, so you know BC and you know AB. So if AB is 7 plus 5 equals AC. Combine like terms and you get 12 is equal to AC. So AC is equal to 12. So we have 5 for BC. We don't know what AB is. We don't know the total wins. But we know that AC is 13. The total games that the lacrosse team did in year 3 is 13. So we're going to do this again, where minus 5, subtract like terms, and you get 8. So AB is equivalent to 8. So now that you have found the values and the distances using line segments and the two postulates, what can you do to what questions can you explore? Like, what can you find using the values that you've just uncovered? Well, you can use the values to answer questions that you wonder about this bar graph, or to interpret the bar graph. And we found the values, and we can make statements based off of the bar graph and about the lacrosse team. So, for example, one question might be, if you have about this bar graph, if the lacrosse team did the lacrosse team have the same amount of losses for all of the years? So, for all of the years, the lacrosse team have the same amount of losses, the same value of losses. So we know that it would be BC for the losses. So let's go look at the losses for year 1. BC is 5. Year 2, BC is 5 again. And year 3, BC is 5 as well. So the lacrosse team did have the same amount of losses for each of the years. Did the lacrosse team gain more wins and losses for every single year? So if we look, the wins would be AB for each year. So let's go look at every single AB and see if it's greater than BC, the losses. So AB here is 6, and that is greater than BC, which is 5, the losses. AB, the lacrosse's wins for year 2, is 7, which is greater than BC, which is 5. And then year 3, AB is 8, and that is greater than 5. So yes, all of the lacrosse team gained more wins and losses for every single year. How many more wins did the lacrosse team get than losses in the 3rd year? So, how to answer that question is that we know that there's more wins than losses in the lacrosse team got in the 3rd year. So we can subtract AB, the total wins, from BC to get the value for how many more wins did the lacrosse team get in the 3rd year. So it'd be 8 minus 5, which is 3. Thank you.